and then all you do is just put your drink down on the bar and you leave it alone. I'm not sure you expected that to happen, and neither did I. So let's try and explain what's happening. Electric fields apply forces to charges. Why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees? Welcome back. What we're going to look at today is gears, how they work and some of their applications. You'll notice that Laika the space dog's not with us again today. She's off on yet another one of her world travelling missions, and more of that at the end of the video. So we were in Germany over the Christmas period, and we took baby Barry with us, and we spent an afternoon with some friends, and they had a massive box of Lego. And inside that Lego, I noticed there were some plastic gears, and he was beginning to play with those. So I thought, here we go, that will make an excellent FJ's physics video on gears. So as soon as we were back in the UK, I couldn't resist temptation to buy Barry a present. In fact, I was buying it for me, really. But anyway, he gets to play with it as well. And it's a Lego Duplo set. And I think they called it My Carousel or something, though it doesn't have a name on it. But there's some gears in here. So let's get this out of the box, build it, and have a look at how the gears work. So there we go, we've got it built, and here are the gears working and all the little tables turning. So let's take it apart and just look at the interesting bit. Let's look at how the gears work. Right, so first things first, let's have a look at a few of the properties of gears. Some of them are very obvious to begin with, but it's worth pointing out that one use of gears is to change the direction of rotation. And it's quite important you understand this, because we'll look at meshing more than two gears in a minute. So if you've got something that's rotating clockwise and you want something else to rotate anti-clockwise, a really easy way to do it is with two meshing gears. And obviously if you turn this one anti-clockwise, the other one will always turn clockwise. So a first use of gears is to change the direction of rotation. So now you know something about the direction that gears turn. Let's add a third gear and mesh three gears together. Now this is an interesting problem. If I turn this one, or this one, or this one, they're all locked. Now if you think about it, it's sort of obvious and then sort of isn't obvious that three meshed gears cannot turn, because this one, if I try to turn it clockwise, will turn that one anti-clockwise, and then this one will try and turn clockwise. Now if you think about that, well that's okay, isn't it? Because this one will turn clockwise and that one will turn clockwise as well. So shouldn't they turn together? But if you think about it, as I turn this one, this side comes up, that side goes down, this side comes up, that side comes up, and this side is trying to go downwards. Quite a complex explanation there, but there's no way that three mesh gears in this simple arrangement can turn at all. They lock each other solid. So that was our second property of gears that we looked at, that 3 intermeshed gears can't rotate. But of course I could move the blue gear to this side, and now they do rotate because they're not all interlinked. This is an interesting arrangement, and we're going to look at this one a little bit later on in the video, where this one turns and the effect is to turn the yellow one, and we've got a gear in the middle here, and we usually refer to that gear as an idler. So now for the next most important thing to know about gears. Some gears have the same size, and some gears are larger than others, but still have the same size teeth cut in them. And if you count the number of teeth, I've counted the teeth on these, 2, 4, 6, 8, and 8 on that one, we can look at the ratio between the number of teeth. And there's 8 teeth on that gear and 8 teeth on that one. So we've got a gear ratio of 1 to 1. And what that means is that if I rotate this through one rotation, the other gear as well will rotate through one rotation. But what happens if we use a gear that's larger and has got more teeth on it? So let's change the gear ratio and put in the red gear that's got 12 teeth on it. Now, if I turn the little one here, you'll realise that this will rotate through 8 teeth and will pull through 8 teeth from the red gear. But if you think about it, for every rotation of the yellow gear, we'll only move 8 teeth of the red gear. So we haven't got a 1 to 1 ratio here, but we've got one rotation of this gear only causes 2/3 of a rotation of the red gear. And if you think about that, what that's doing is changing the number of rotations that we get out compared to the number of rotations that we put into the system. Now, this gear ratio business has some really useful properties. If you think that the yellow gear is put on a rotating shaft and you realise that every rotation of the yellow gear only causes 2/3 of a rotation of the red one, then this is a speed reduction. So this one could go round faster and the red gear will go round slower. It's acting like a kind of a gearbox, and it's the gear ratios that are important here. I don't think you need me to demonstrate what would happen if I just put 2 8s together. Obviously 8 teeth going around will pull 8 teeth around, so this is a 1 to 1 gearbox. But if we look at things the other way around and I put the 12 tooth red gear back and I rotate this one, so I make this the input shaft and that the output, then if this goes round once, it's moved 12 teeth round. And the yellow gear's got 8 teeth on it, so this must have pushed 12 of those around. So to do that, this one must have rotated 1.5 times. So this gearbox speeds up the speed of the output rotation. Now, if you remember earlier, I mentioned idler gears, and this is something that's really weird and counterintuitive. What I'm going to do is I'm going to have the input shaft here, a gear in the middle that we'll call the idler, and this gear will be the output shaft. Now, look at it. This has got 8 teeth on it. This has got 8 teeth, and I've put a black line up there to show that tooth pointing upwards and this one pointing upwards. And the weird thing is, what happens if I rotate this one through a full turn? Remember, the idler gear is much bigger. Well, watch what happens to this tooth. So I'm going to rotate this one through one full turn. There we go. And back to where we started. And you'll notice that this tooth is exactly where it started. It's really weird, isn't it? But obvious if you think about it, that having an idler gear of any size doesn't affect the ratio between these two. So these are 1 to 1 gears, and so it doesn't matter what the idler is. If this one pushes 8 teeth past, this will turn past 8 teeth and will turn that 8 teeth round. So the ratio will remain 1 to 1. What you've learned there is an idler gear doesn't change the output gear ratio. Now for a slightly more complicated bit. But you all know that when you cycle on your bike and you want to go uphill, you pedal like mad and the back wheel turns quite slowly. But pedaling fast makes it easier to go up the hill. What you're doing with your pedals is you're turning a small gear, like this little yellow one here. And the red gear is the one that would be on your back wheel. Now, how does this work? It's actually easier than it looks. Gears behave like levers, and if you look from here to here, this distance is quite small and this distance is bigger. Shall we say, for interest's sake, it's twice as big. Now, if the yellow gear presses on the red gear will feel the same force, but it will feel that force over a longer lever. And if the lever is twice as long, the moment on the red gear will be twice as big, and so it will be easier for the little yellow gear to turn the red gear. But of course, remember, you have to do more rotations of the yellow one to turn the back wheel because there are less teeth on it. Now, I think from what we've done so far, it's pretty obvious how you go fast on your bike. You swap the gears around, so you turn with your feet the red big gear, and for one turn of the big red gear, you get lots of turns of a smaller gear on the back wheel, so the back wheel goes faster. But remember that it's a leverage effect, and the force from your red gear acts on a shorter lever on the yellow gear, so it can be harder to turn the back wheel. So I do hope you enjoyed that video and you learned a little bit more about how gears work and their properties. I'll be making another video soon, and I look forward to seeing you then.